Okay, what we're going to look at now is how we will convert our compass course to a true course. Now there's two corrections to make in order to convert a compass course to a true course. And the two corrections are called variation and deviation. The combination of these two corrections make up what is known as the compass error. Now this compass error can only be calculated using the compass course of the vessel. This is because the correction known as deviation can only be calculated using the ship's head. Once total compass error has been calculated, however, this can be applied to any compass bearings taken whilst on that compass course to calculate true bearings. Remember, apply the compass error to bearings only after it has been calculated using the ship's head. And it will of course follow that if the vessel changes course, then the compass error will change. So let's examine the two corrections. First of all, we'll have a look at deviation. Now the vessel's compass is near to various sources of magnetic interference. That could be iron, metals, electrical currents, etc. And these will cause the compass to deviate from magnetic north. The deviation is expressed as either east or west. It's important to know that the deviation is specific to each vessel. So when a vessel has been built, it will be swung through 360 degrees and the deviation will be calculated at regular intervals to form a deviation curve. Now the deviation curve can also be expressed in tabular form. So let's have a look at a curve and a deviation table. So this is our deviation curve here. And as you can see on the left hand side, it says compass heading right through from 0 to 360 degrees. And at the top we have west deviation and east deviation, the values ranging from 0 through to 10 degrees. And as the compass is swung through the 360 degrees, you can see the curve is formed, indicating the deviation for this particular vessel. Now, as well as a deviation curve, it can also be expressed in tabular form, and here we see a deviation table. So if we look at a ship's head by compass of 140 degrees, we can see that the deviation there is 7.5 degrees east. So that's deviation, which is dependent upon the ship's head and is specific to each individual vessel. Okay, so let's look now at the second correction, which is called variation. Variation is caused as a result of the Earth's magnetic pole not coinciding with the true North Pole. This difference is called variation, and it's expressed as an angle between true north and magnetic north, east or west. Okay, so let's look at the compass rose on a chart. Here we're looking at one on a chart, and we can see that on this particular chart, in the centre of the compass rose, it mentions variation 8 degrees 35 west in 1979. And if we look towards the top here, we'll see true north 0, and then we'll see magnetic pointing to 8 degrees 35 minutes west of true north. So in 1979 this was the variation on this chart. This is the year 2011. As we can see to the right, it now talks about a small correction that's made annually. And on this particular chart, variation is decreasing about 5 minutes annually. So from 1979 to now, that's about 32 years, 5 minutes a year. So it's decreased by 160 minutes, which is 2 degrees 40 minutes. So our variation now is actually 5 degrees 55 down from 8 degrees 35 west. Now variation does actually vary throughout the world. So if we look at what's called an isogonic chart, that will show us there that variation starting off at 0, west and east, goes right through 1 degrees, 2, 8, 10, 12, and the further north or south you go, the variation is considerably higher. So let's now look at an example of applying those corrections that we've talked about so that we move from compass through to true. So I've written down here, starting off with a compass course, and let's call that 260 degrees compass. Now what's particularly helpful when calculating these initially is to have sort of an acronym or a little ditty that you can use in your mind to remember which sequence to calculate going from compass to true. And I've written one at the top here, CDMVT, Cadbury's Dairy Milk, very tasty. So that indicates we go compass, deviation, magnetic, variation, true. So let's say our deviation is 4 degrees east. Now we need to know whether to add or subtract that amount to get our magnetic value. And I've written here another acronym, CADET, and we can say that if we go from compass to true, then we add east. So going from compass to true, add east. We are going from compass to true, our error is east, therefore we add it. So our magnetic value is 264. Let's call our variation 7 degrees west. Now if we go from compass to true and we add east, it would follow that we need to subtract the westerly value. So that will give us a true course of 257 degrees. So we started off with 260 compass, applied the deviation, then applied the variation to arrive at a true course of 257. So let's write these two values here, deviation 4 degrees east, variation 7 degrees west. So if we want to now calculate our compass error, then in this instance it is going to be 3 degrees west. So if we'd had 2 or 3 compass bearings that we'd taken, we would now apply that 3 degrees west to the bearings to get true bearings. Just write another example here. If we had, say, deviation of 2 degrees east and variation of 3 degrees east, then our compass error would in fact be 5 degrees east. So if both values are either east or west, then we would add them together to form the total compass error. If one value is east and one is west, we subtract one from the other and it is named after the greater value. So in this instance, 7 west was the greater value from 4 east, therefore the compass error would be 3 degrees west. So that's converting compass to true. The very important thing to remember is that you need to use the ship's head, and only the ship's head, to calculate the deviation. And that when we're setting it out in sequence, we go from compass, deviation, magnetic, variation, true, Cadbury's Dairy Milk, very tasty.